Hey everyone, welcome to the 1-5 notes on angle relationships. In the last section, we looked at 3 types of individual angles. So in this section, what we're going to do is talk about pairs of angles. So pairs does mean they're 2 angles together. So we are going to look at 5 different pairs of angles that we're going to use not only in this section, but throughout this school year. All right, so the first one is adjacent angles. Adjacent angles means that, first of all, they're in the same plane, but they have a common vertex, so the same vertex, and they have one common side, but they don't have any interior points that are in common. So for example, if I was to look at angle PQR and then angle RQS, PQR has all these interior points, all of these are inside points. RQS has all of these, none of them are the same. So what they do share is this side and this vertex. So adjacent angles basically does mean when, adjacent is a word that we use in our everyday language. If somebody has a room adjacent to yours, that means it's next to it. You share that wall. Well, adjacent angles next to each other, and they share a side and a vertex. Okay, the next one is going to be vertical angles. So vertical angles are 2 non-adjacent, so they're not next to each other, that are formed by intersecting lines. So here in this picture, we have this line and we have this line. The vertical angles then are the non-adjacent ones. So here, 1 and 3, these are vertical angles. 2 and 4 are also vertical angles. Now what we're going to add here is that vertical angles are congruent. So I could show that in the picture using arches. 1's congruent to 3, 2's congruent to 4, 100% of the time. All right, so in this, you would say angle 1 is congruent to angle 3, and if 2 and 4 are vertical angles, angle 2 is going to be congruent to angle 4. Next one, linear pair. In the word linear, you could see kind of where we're going with this. You could see the word line. So linear pair, the technical definition is adjacent angles. So remember, we just discussed adjacent angles. They share a side and they share a vertex, and they're next to each other. So these non-common sides form a line. So in this picture, we have 1 and 2. These are a linear pair. 3 and 4, those are a linear pair. 2 and 3 are a linear pair. 1 and 4 are a linear pair. So there's 4 different sets of linear pairs when you have this X formation of 2 lines intersecting. You're going to get 2 pairs of vertical angles, 4 pairs that are linear. So here's the property with linear pairs. Linear pairs have a sum of 180 degrees. So when you add linear pairs, you will always have the 2 of them add up to 180, which makes sense, right? If we look at angle 1 and angle 2 here, if they come together and form a straight line, yes, they're gonna have a sum of measures that's 180. So how we would write this, if angle 1 and angle 2 are a linear pair, that would mean the measure of angle 1 plus the measure of angle 2 is 180. Over here, measure of angle 2 plus the measure of angle 3, that equals 180. And then the same could be said for 3 and 4 and 4 and 1. All right, so let's try our first example here. We have a picture, we have an X formation, 2 lines intersecting, and we want to find the value of X and the measurement of angle cat. All right, to find angle cat, I'm going to need to find one of the adjacent angles, and then it's a linear pair, but we'll get to that in 1 second. All right, so what I notice here is that we have a set of vertical angles. So those 2 angles equal each other. So I know 16x minus 20 is going to equal 12x plus 7. You have to decide when you have this sort of picture, are they vertical angles that equal each other, or are they linear pairs that sum up to 180? So I'm going to solve this for x. I'm going to subtract 12x from both sides. I get 4x minus 20 on the left equals 7, Add 20 to both sides, you get 4x equals 27. X is 27 over 4. I know that most students and even the teachers, if we get an answer like this, we're like, wait a second. That seems a little bit suspicious whether or not that's right. So just double check your work and make sure that it's fine, and it is. Another thing you could do is plug that in for both of these equations, plug that value of x in, and see, will you get the same angle measure? So I'm going to go ahead and do that. I'm going to plug it in here, 12 times 27/4, right? Because that's what I got for x, plus 7. 4 goes into 12 3 times. 3 times 27 plus 7 is going to equal 88 degrees. And now, just because I'm a little bit nervous that the answer wasn't right, I'm going to do 16 times 27 over 4 minus 20. 4 goes into 16 4 times. 4 times 27 is 108. 108 minus 20 is also 88 degrees. So because these two answers were the same, I got an 88 here and I got 88 here, even though the answer being a fraction made me a little bit nervous, I know that it's correct. And that's because vertical angles are congruent to each other. Okay, so now we have to find the measure of angle cat. That is this angle right here. And so angle cat and these angles, they're linear pairs. So they have to add up to 180. So to get cat, I'm gonna do 180 minus 88 degrees. And it equals 92 degrees. Okay, again, remember, 88, and I could have written it this way, 88 plus the measure of angle cat equals 180, subtract 88 from both sides, and you do get 92. All right, the next two pairs of angles that we're going to talk about are supplementary angles and complementary angles. I do believe I just used the word supplementary earlier in this slideshow, and maybe you were like, what does that mean? Well, now you know. Supplementary angles are two angles that add up to 180. Complementary angles are two angles that add up to 90. So I know that students always know. They're like, okay, one of them is 180, one of them is 90. I don't know which is which. So here's how I tell my students to remember that. If somebody pays you a compliment, okay, they say, you're so smart, you're so fun, you're so caring. They're saying nice things. Compliments are nice things. And human nature, we're like, no, I'm not, no, I'm not. But deep down, you're thinking, you know what? They are right. So if someone gives you a compliment, don't argue with them. Say, you know what? You are right. A right angle is a 90-degree angle. So that's my little way to help you distinguish the two. Because again, kids always know, oh, one of them is 90, and one of them's the ones that add up to 180, which is which. Now you know if someone gives you a compliment, they are right. All right, so here we're going to find the value of x and the measure of the angles. So for the first one, what I see happening here is we have two angles that are a linear pair. These two angles add up together to 180. So I'm going to write that. 10x minus 5 plus 4x plus 3 equals 180. These are supplementary angles. Again, I apologize for using that term. I do think I did earlier without teaching it to you first. So 14x is going to equal 182. X is going to equal 13. All right, let's find the measure of these angles. This one is going to be 10 times 13 minus 5. 10 times 13 is 130 minus 5, 125 degrees. Now I know because they're supplementary, they're a linear pair, I know that when I plug it in to Kij, I better get 55. If I didn't get 55, I found X incorrectly. So I'm going to do 4 times 13 plus 3. 52 plus 3 is 55 degrees. Okay, so those are the measures of the angles. Over here, we have this little symbol. That means a right angle. So I know that these two are complementary. They add up to 90 degrees. So I add them and equal them to 90. Now let's combine like terms on the left side. So we are going to combine 2x and x, giving us 3x. And then 2 and 1 is plus 3. And this equals 90. subtract 3 from both sides and divide by 3 gives us a value of 29 for x. Now we have to find the angles. Let's plug that in. 2 times 29 is 58. 58 plus 2 is 60. And then this angle is 29 plus 1. That gives me 30 degrees. 60 degrees. And so those two do add up to 90. So I know that I did this problem correctly. All right, so now let's do a word problem from this section that you're going to see quite a bit. It's going to be in the classwork, it's going to be on the review, it will be on the test. You will be assessed on problems like this, so please make sure you know how to do these and pay attention to how to do these. The measure of a supplement of an angle is 60 less than 3 times the measure of the complement of the angle. Whoa, that is a mouthful, and that is just kind of hard to wrap our minds around. So we're going to break this up into easier little pieces. If we use x to represent the angle, how are we going to represent the supplement? How are we going to represent the complement? Well, the supplement, keep in mind, is supplementary angles add up to be 180. They have a sum of 180 degrees. So if I said x is the angle, okay, so x, the angle. If I said the angle is 50, what would its supplement be? Hopefully you're thinking to yourself a number. So if the angle is 50, what's its supplement? 130. If the angle is 100, what's its supplement? It's 80. If the angle is 10 degrees, what's its supplement? It's 170. So hopefully you're seeing the pattern here that the supplement of the angle is 180 degrees minus whatever x, that angle, whatever that is. Okay? Now let's do the same thing but with the complement. The complement means if two angles are complementary, that's two angles who have a sum of 90 degrees, right? Because if somebody gives you a complement, they are right. So if the angle is 10, the complement's 80. If the angle is 50, the complement is 40, and so on. So hopefully you see that little pattern is you take 90 minus whatever the angle is. So if the angle's 10, the complement's 80. If the angle's 40, the complement's 50. Supplement, again, if the angle's 10, supplement's 170. So the way we express the supplement is you take 180 minus whatever the angle is, and then the complement is 90 minus whatever the angle is. So now let's go back to the actual problem here. It says the measure of the supplement of an angle is. So let's write that out using equations and equal signs and plus signs. So the measure of the supplement of an angle, so we just said the supplement of an angle, we said right here, is 180 minus x. The word is, in a math problem, in a word problem, is always this equal sign. 60 less than 3 times the measure of the complement of an angle. So when it says 60 less than 3 times the measure of the complement, 60 less than means subtraction. It doesn't mean is 60 less than or 60 is less than, okay? Where that would be an inequality. 60 less than 3 times the measure means you're going to write 3 times the measure of the complement because it's 3 times the measure of the complement. So 3 times the measure of the complement we have up here in blue, 90 minus x, and 60 less than that is going to look like a minus 60 at the end. So again, let's go back and read what the problem said. The problem said, and as I'm reading this, look at the equation I wrote and let's make sure it matches up. The measure of the supplement of an angle, well, we said the supplement of an angle is 180 minus x, is, in a math word problem, is always going to indicate an equal sign. 60 less than 3 times the measure of the complement. So is the right side of my equation here 60 less than whatever 3 times the complement is? It is. So I'm going to go ahead, clean up the right side of this equation. The left is just 180 minus x. This is going to equal 3 times 90 is 270 minus 3 times x, because I have to distribute here, and then minus 60. I'm going to continue to clean up the right side because I still have some cleaning up to do with the 270 minus 60. 270 minus 60 is 210 minus 3x. And now let's solve. I'm going to add 3x to both sides. So I'm going to plus 2x equals 210 bring it up here because I'm running out of room. 2x is going to equal, I subtract 180 from both sides, I get 30. X is going to equal 15. So the angle is 15 degrees. As a way to check your work off to the side, if the angle is 15, its supplement is 165, its complement will be 75. These are the three angles. So this is the supplement, this is the complement. So what I'm gonna do right now is 3 times 75, because I'm gonna see what is 3 times the complement. It's 225. So I'm plugging into the equation. Is the supplement, which is 165, going to equal 3 times the complement, 225 I mean, minus 60? Yes, I get 165 equals 165, and that works out perfectly. The key to these word problems is always remember that the supplement of an angle, the way we express it, if x is the angle, the supplement is 180 minus whatever the angle is, and then the complement, the way we get it, is 90 minus whatever the angle is. And then you have to just be careful with how you use your signs, what's being doubled, if it's being tripled, if you're adding, what have you. All right, so perpendicular lines are the next thing we're going to talk about. And perpendicular lines are 2 lines that are going to form 4 right angles. If you notice in this picture, there's only one, because it would look kind of strange if I put all 4 of them. It would just look like kind of a little box inside, and we don't typically see that. What we know is if we have 2 lines that are intersecting, and if one of the little corners shows a right angle, we know all of them are right, because they are, let me erase this for a second. We know that these are linear pairs. And the way that I know that they all have to be 90 degrees, well, a few ways. Vertical angles, right? So if that one's 90 degrees, the one that's across from it also has to be 90 degrees. And then I know we have linear pairs here. So linear pairs add up to 180. So if one of these angles is 90, the other one has to be 90. And so then, therefore, all of them are 90. But to write all of those little squares is unnecessary. We don't have to do that. Next thing is, because perpendicular is such a long word, we don't write it all the time. The symbol for perpendicular is this like upside down capital T. Okay, that is the perpendicular symbol. So when you see this, the way you would read that out loud is L is perpendicular to M. Last example for these notes. It says find x and y so that KO is perpendicular to HM, so that the two of those are perpendicular. So KO is this line, and HM is this line. And I highlight it because I have other rays and segments here, so just to keep things clear for myself, I will highlight them. So as I drew that in and highlighted it in, the first thing I noticed is this angle right here, if they're going to be perpendicular, that would mean 3y plus 6 degrees is going to equal 90. Because if those lines are perpendicular, that's going to be a 90-degree angle. So 3y is going to equal 84. Y is going to equal 28. I can always check that by plugging 28 back in. 3 times 28 is 84, plus 6 does equal 90 degrees, so I know that that's good. Now let's find x. If you notice here, x and this angle and that angle, those will have to add up to be 90 degrees. So 3x plus 6 plus 9x, that's going to equal 90 as well. So 3x plus 9x, 12x, when I clean up the left side, plus 6 equals 90. 12x is going to equal 84. And then divide both sides by 12, I get x equals 7. So I get x equals 7, y equals 28, and I am done. All right, so tomorrow you will, or not tomorrow, whenever your next class period is, you're going to work on the 1-5 classwork. Thank you so much for watching. Have a good day. Bye.